It's great to be here. We've been partners of Couchbase for 3 or 4 years now, and been awesome to work with, so thank you for the support, appreciate it. And for this presentation, we'll just run through a quick overview of Knowi, maybe see a couple of things that we might have seen previously in the keynote today, and what Steve did with the Red's presentation earlier in the afternoon. And also cover a few things around machine learning on top of Couchbase data as well. So those are the things that I wanted to discuss. So, but before I get into that, maybe start with a few words on how the company was started some years ago. So in my previous incarnation, I used to run product and engineering for a company that had 20 different silos of data, right? So, and for us to make sense out of that data, it was putting together ETL teams and data warehousing, data preparation, and then data visualization tools just to get from the raw data across a multitude of data sources to the visualizations and the dashboards and insights. So now combine that with a couple of fundamental things that are happening in the marketplace, which is the enterprise stack has changed in a big way over the last 7 to 10 years, right? So you got your relational databases that had a lock in the enterprise. Now that's broken out into, you have your relational databases, you have your NoSQL databases, you have your REST APIs, you got your file-based data, and so on and so forth. So the demands on analytics is more intense than ever. You have your business intelligence tools that are basically architecturally built for structured relational data. So you end up having to put together these large-scale processes, tools, and so on and so forth. So our objective to start off was to simplify this process, to say, how do I get from data to insights and give you that agility within the enterprise to go from, you have data wherever they may be, it might be in Couchbase, it might be in somewhere else, to get to those insights quickly. And then the other third piece is, you hear a lot about machine learning and AI, right? So you have teams generally within enterprises that are basically doing these machine learning type use cases, which essentially is how do you predict based on your historical data what's expected to do next and what actions you can take. So the Knowi platform itself, it basically has a couple of different components to it. We enable native connectivity into databases like Couchbase. So you can type in nickel and get results right away. Then you can do visualizations and you can take those visualizations and embed those inside your application if you like. Then also do higher order things like machine learning, where you can you can build models and then apply those models on top of data from Couchbase and other sources too. And the other key thing we do also is multi-data source joins. So within the enterprise, you may typically have more than one data source. And then how do you combine those from analytics standpoint without having to do a whole ETL jiggery-pokery basically. So a couple of things we do. The reporting dashboards, those are the lower, so if you're a Couchbase user, you can basically type in nickel queries, get your visualization right off the bat, share that with your internal users, embed that inside your application. Then you can collaborate and within the same team or other teams or inside your embedded applications itself. And then you can also take actions from the data as well. So you can basically say in these, you use a combination of Couchbase eventing as well as our own triggers on the data based on conditions you get to drive some actions. So it's, you get your data to insights and then also action and also predictions along the way. That's basically what we do. On the Couchbase Knowi side, so we provide end-to-end analytics on Couchbase. You don't need ODBC drivers. You don't need to shoehorn that data into relational form. You don't need to flatten the data out for nested structures. We leave the structure as is, so we understand the documents that Couchbase stores, and you've chosen Couchbase for a reason, right? Or you've chosen other databases for a reason. So we go in deep for each of these data sources. And then you can instantly visualize the data. You can blend that data with other relational or non-relational data on the fly. And you basically have these federated queries that you can run real time on the database that you can push down without ETL, or you can also run that asynchronously and then query and store those results too on it. So with that, I'll just get right into a demo. So the demo has a couple of different pieces, is the way I was thinking about this. So you connect to Couchbase database live, we'll put some simple queries together, get some visualizations from it. We'll do a bit of the Reds use case where we'll mimic a baseball game where the stadium is real-time seating charts are populated. And we'll get into some machine learning use cases where we'll take people who are using credit cards, how likely are they likely to default? And then some dashboards and visualizations on the fly as well. So with that, I'm going to switch this up, get into.
Are you going to take questions at the end, or can we ask questions now?
You can fire away, yeah, especially while I'm.
The question is, you mentioned that we have different data sources, correct? So, and we fire the same query, and it goes across different federated data. Is it totally transparent? So if I have data stores at different sources, how do you bring that to Knowi's UI to understand that?
Sure, yeah, I can go through that. So there might be two questions there. If you have multiple, some customers have the same database and they just have different silos for each customer. So we support that, so you can run one query against 20 different databases, or you can have one database is Couchbase, another one is SQL database, for example, and you can federate the queries in parallel, and then we can join the two together.
Yeah, so some even I have data in Hadoop,
yeah.
Or somewhere else you just
Exactly, yeah. So we'll push down those queries, and then the results of it, we will just smash them up, basically. And I can walk you through an example as well. So let me take a quick end-to-end use case with Couchbase. Keep it very simple first. So here I'm connecting to a Couchbase instance in our cloud. I'm just going to give this a random name. And then I've connected to Couchbase. The next step is executing queries. So there's no driver configuration or anything like that. You just, off you go. Type your nickel query in, or you can generate them as well. So in this case, if I have a restaurants bucket that has a number of nested and top-level attributes, so I'll take the coordinates, maybe a couple other fields, cuisine, name, and then you have your nickel query generated on the right-hand side, right? And you can override that, type it in if you like as well. So do a quick preview. So this is querying Couchbase live. While it's doing that, I'll just do this as well. And then we should get the data back. And one of the fields that's returned is coordinates, which is an array of lat longs, right? So we keep that as is. I'm just going to save this as is. So this is a little bit more the technical view. So you know where the data is. You're basically stitching the data set together. And then let's say I'm creating a dashboard. And this is a bit more of the business-friendly view. So you can basically start creating, if you saw the keynote today, Sachin had a similar map for connected cars this morning. But you can change the visualization type. There's about 30 different visualization options. And then also do things that filters and things on the fly. So if you're looking for restaurants within Manhattan, for instance, right? And being able to go in and say, hey, that's a restaurant, Chinese restaurant down in the Manhattan area. So basically what I've done is I've connected to Couchbase, run a simple query, visualize it, and then I can share this and embed this dashboard any which way. So that's example one. So now let's take a little bit more of a complicated example, not too complex. So I'll use a machine learning use case. We'll train a model that takes credit card default data that historically that people are defaulted on based on a number of attributes. And we'll put a model together, and then we'll use that model on top of Couchbase data to predict what the likelihood of someone defaulting on the credit cards are. And then we'll put some visualizations and things together. So this is the model creation bit. So we'll say default credit card. And this is my training data set. I'll just do a quick transformation. Cloud9QL is a transformation syntax that allows you to do manipulations on the data on the fly. And it's something that we've developed because we couldn't find anything that did it. So now we basically do some analysis on the data and then also do a data preparation on this, on prepping the data set for the ML model. So I'll skip through most of this. It allows you to basically identify outliers as you build a model. But the main thing is the features that go into this model. So there's a few questions we'll ask you. I'll skip those. And select the features that go into making the model, right? So in this case, all of them, I want to select all of them except for maybe the ID. And then you can run this against a number of algorithms. And once I let it train, it's going to go and execute against these algorithms to figure out which is the best fit. So in this case, logistic regression, we've got 80% correlation, so that's a pretty good model that we can use. So we can save that as a model that we can use against incoming data. So typically in machine learning projects, the challenge is it's a separate initiative, right? So you have to go and get the data first. Then you got to prep it, analyze it, and then you use R and Python. And then once you create a statistical model, how do you then integrate that back into the workflow? So these are the pain points that we address on the ML side. So it's an end-to-end platform. You have data in Couchbase, you build your model, and then you apply that on top, and then you have your prediction seamlessly as part of your application. So now I've published this model, so now we can use this on incoming data, right? So in my Couchbase data that has the analytics service enabled, I'm calling into a credit cards data set. So if I do a quick preview on this, so this is what the data looks like. So now if you apply the model, it will give us a predicted value of whether this customer is likely to default or not, right? So I can apply this model on top. And now if I hit preview. So this guy here will tell us, so if I'm looking for a data set that I want to take some action on people who are likely to default, that's going to give me that. So we've created the model, applied that on top of incoming data, and then that gives us that data set. So it's a combination of that AI plus BI. You have your hindsight, what's happening, and then you have your what's expected to happen in the future. And then you can take actions from this too. And to answer your question, if I want to do a join across multiple data sources, let's say one of the fields is, I think, gender. And let's say I want to connect to a MySQL database where I want to join, where that database has a label of the gender. So in this case, querying Couchbase, querying MySQL, and applying also the model on top. And if I do a preview on that, we should have label in here somewhere. Right, so that label for MySQL is there too. So this is an example of federating queries across multiple data sources in parallel and then basically joining them together. So once I have this, I can save that into a data set that I can do analysis on. Right, so if I go back to the dashboard I created earlier, and just add that, even though they're totally, completely different data sets, I can start doing analysis on this to say, hey, let me get the count by gender, where the likelihood of them defaulting is high, right? So you just do a count on this. So that would give us a count. If I want to do some visualizations on that, you put that into a pie chart, save that as a visualization. And if I want to do something else, also do age range to the mix and put that into a different type of visualization. You get your age buckets by gender. So, you know, the younger you are, more likely you're basically the default on your credit card, basically. That's what it says. So that's the ML use case. And then I'll just end with a real-time visualization use case. And if you've attended Steve's session, there might be some overlap here, but I'll just walk you through it quickly. So we have one of the visualization options we have is an image map, right? So this is useful in stadium type use cases where you can have a map with XY coordinates you can plonk in, as well as things like IoT type use cases where you might have a floor plan with, you know, things happening inside it. So let's say, what is that, stadium? So you got the stadium visualization, right? Right now is empty. An, could you mind putting some data into Couchbase? So An's going to run a script that's going to put real-time data into Couchbase instance. And what this is doing is connected to Couchbase, runs a nickel query, grabs a couple of fields, and what you're seeing now is how the seats are filling up, you know, mimicking how the seats are filling up, essentially. And you can basically zoom in and say, hey, what's the profile of this customer who's sitting down here, for instance, and so on and so forth. So so the way this is built up is you've got your, if I look at the query, this is coming from a simple query that's hitting a stadium data set where it's getting that, you know, the seat XY, row modified, and so on. So that's what I got. Yeah. Thank you. Sure. Yeah. So we have a couple of options. You can. So the question is, how can they use the embed API essentially to embed dashboards inside the application, right? So we have a single sign-on API. So a user in your system can be mapped as a user in ours with rights and permissions. And so we have a REST API that allows you to do that. If you have a dashboard template and then you pass in parameters that are encrypted way, you can do that too. So it's useful for view-only dashboards where you want a user coming into your system has a specific view, then that's handy for that. So those are the two ways, basically. Yeah. No, it's querying the database either real time, or we will query the database, and if you for larger data sets, you can set it to cache the results. So we don't transfer the raw data.
Okay, but if you access over the internet.
Yeah, so we have a couple of ways to do that. So we can either connect directly into a database. You can have an fully on-premise version that's inside your network. And then there's a third option where you can run an agent inside the network that does not require us to open up firewalls on your end. So the agent is basically a headless process that facilitates that communication with the database and then sends the data, the resulting query data to us. Yeah.
Does it sit on an application stack? And what redundancy is now?
Yeah.
Is it a cluster solution, standalone solution?
Yeah. So we provide cloud and on-premise, and both are clusterable. And cloud is clustered by default. On the on-prem, depending on the bundle we give you. We have a Docker option, and then that's got cluster set up in itself, or you can set up your own cluster as well. So then it gives you that failover load balancer. And then we have different components. So we have a UI-facing components that the users hit. And then the processing bit, you can isolate that separately. So you can run those queries not on the same servers that run that display the dashboards. Yeah?
With respect to the ML use case,
Uh-huh.
are you using the same MQL, NSQL to get the ML query done, or is it separate? And is the ML query running on the same analytics node, or could you elaborate on that?
So, so are you talking about in the preparation stage where there's a QR bit?
Not only the training time.
Yeah.
After training is done.
Yeah.
In a real-time case.
Okay.
Typically in a microservices world, you run the ML service as a separate service.
Yeah.
But here I'm visualizing how's it done.
Yeah, we basically expose something on our end, and so it's containerized on our end basically. But if you've done an ML model separately and you have an API endpoint, you can use that too. So you can basically just join that with your Couchbase data or other data.
So the ML query during runtime is not going to the analytics data.
No, not the ML piece, no. Yeah. So in the example I showed, it goes into analytics service first, grabs the data, and then does the ML bit on top.
Yeah. So I'll just add to that over here. Right now, the way analytics is set up is that ML natively is not available within analytics. One of the things that we've been considering is user-defined functions, wherein you can bring in your ML models that can be executed in analytics data natively. So it's one of the things, like Peter was saying earlier, on the whiteboard in my office, and we are actively considering that. So if there's interest, we can talk offline about how you could potentially do it with Knowi, and if you want to do it natively within analytics, how that can be enabled or will be enabled in the not so distant future.
Yeah, interesting problem.
Yes, sure.
Any other questions?
What about the licensing model? Because you are the right guy to.
$1 million now. No, it's, we have a couple of different options. So there's a cloud option. So you can basically just go to knowi.com and then sign up for a trial, and then talk to somebody, and then we can guide you through all the options there. Then there's an on-premise option. Typically, it's enterprisey, and that it's based on the number of users, essentially on the on-prem. On the cloud, there's a few tiers based on number of users, and then on the smaller ones, we also have widget limits and stuff too. So.
Basically, number of users.
Exactly. Yeah, yeah. And the number of users, it's basically a categorization of internal users and embedded users if you're embedding the product.
Okay.
Well, thank you. Thanks, Sachin. Thanks, Peter. Thank you, guys.